Good morning, everybody. It is Wednesday, March 25th. It is rainy outside, so we're back here in the plant corner. And another day means another day of geometry review with new markers, you guys. What do you think? I actually love this one a lot. So I thought that we would keep working through our geometry review packet together. Hopefully you've started it because it's due on Friday, remember? So you have your geometry review packet, which is due to me on Friday, and I'll grade those over the weekend. You are all by now working on your geometry cities, and some of you have started sending me pictures of your progress, which is awesome. Okay? And thank you to everybody who finished their transversals worksheet. I'm going to be putting those in the gradebook today too. But for now, I thought it would be nice for us to continue our perimeter review by moving on to circumference, which is basically the perimeter of a circle. Okay? Oh, we got some weird glare. There we go. So we know that the area of a circle is something that we find by multiplying pi, which is this idea, this ratio, times the radius squared. Now, the circumference is similar, right? But the area of a circle is the inside of it, and the circumference of the circle is how far you would walk if you were walking around the outside of the circle. And so we find the circumference by multiplying pi times the diameter of the circle. So on your circumference worksheet, there are several circles where you have to find the circumference, and I've put a few up here for us to work on today. And then there are a few word problems. I think these word problems are pretty straightforward, but there's one that I think might have tripped you up, and so we're going to work through that one together. Okay, so let's get started. This first one, let me move you a little bit closer so you can see the board a little better. There we go. All right, so this first one, okay, our first circle has a diameter of 30 feet. Do you see? Yeah, okay. So the diameter goes through the middle, remember, and this problem is really straightforward because, let me get this guy, okay, we know that the circumference is equal to pi times the diameter of the circle, right? And so here we can say that pi times the diameter of this circle would equal pi times 30 feet, okay? Now in this worksheet, they try to trip you up by using different units. So we've got feet, we have kilometers, we have yards. The units don't change the calculation that they're doing, okay? So for this guy, we just have pi times 30, okay? And that gives us approximately 94.2 feet. Now, why did I say approximately instead of equals? Okay. If we were in class, I would pause and give you guys time to think and raise your hand. Okay. The reason we're using approximately instead of equals is that pi is something that we're approximating here, right? So we're saying, I'll put this up here. We're saying that pi is approximately 3.14 in all of our calculations. So since we're approximating pi, this is an approximate circumference. Does that make sense? So the circumference doesn't equal 94.2 feet. It's approximately 94.2 feet. Now, you might be saying, Dr. Garby, that makes math sense, but when I go outside and I use a tape measure and I measure the circumference of something circular in my yard, I don't get an approximate circumference, I get an actual circumference. And I would tell you, yes, absolutely. You would get an exact circumference, okay? But anything that you measure having to do with pi, even our measuring tapes would be an approximation. You could, if you got a measuring tape with smaller and smaller and smaller increments, you would see that the circumference doesn't stop, just like pi doesn't stop. You could even go all the way down and get a measuring tape that has increments the width of a hydrogen atom, okay? And you would still be able to keep going smaller and smaller and smaller. So even our measurements outside, they aren't exact, they're approximate, right? So that's the first one, pretty straightforward. Now, the second one illustrates one of the things I see students mess up on the most when they're learning about circumference, okay? It's an easy mistake to make, and when we're stressed or when we're going through something really quickly, it's a mistake that I see often. So I want to make sure that we know about it, and if we know about it, that we can do something about it, right? Okay. So here, they don't give us a diameter, they give us a radius, okay? And so we know that we need pi times the diameter, but they don't give us a diameter, they give us a radius. Okay, so we could say, because we know a diameter is twice the radius, we can say that what we need is pi times 2 times the radius. Make sense? Okay. And so you probably can't see because this is really small. Here, the radius is 13 1/4 kilometer. Okay? Kilometers, plural. So if the radius is 13.25 kilometers, or 13 1/4 kilometers, okay, that means that the diameter equals 2 times that, which equals 26.5 kilometers. You see why? Just multiply by 2. Okay? And so when we plug this in for 2 times the radius, we can now say that the circumference is approximately pi times 26.5 kilometers, which gives you 83.21 kilometers. And this would be approximately 83 1/5. Okay? Do you see why? So that's the biggest mistake I see people make. And these are the kind of mistakes that are easy to make on Scantron, especially when you're trying to go really fast. And it's been a while since you've done circumference and area, so I want to make sure that we at least know about these issues so that they don't trip us up on a test or even just doing problems for ourselves, okay? So this last one, okay, let me go ahead and put this one up to the camera so you can see. Okay, so this one is 9.73 yards. Doesn't matter. Okay, they give us a diameter. That's all we need. So for this one, pi times the diameter would equal pi times 9.73. Okay, and that would be approximately 30.6 yards. You guys, I love this whiteboard so much. I wish my whole wall was a big whiteboard. I use whiteboards for everything. Okay, so does this make sense? Pretty straightforward. Coming back to you if you're in 7th or 8th grade and you haven't done this for a while. Okay, for my 6th grade, this is new, so I hope this is also making sense for you guys too. Okay, so this is the first kind of problem on that worksheet. And now let's do one of the word problems. Oh, man. While I'm erasing, how are you guys doing? Did you figure out some kind of schedule that's helping you stay on track and getting all your stuff done? It can be really hard when you're at home to make sure that you're staying on task and staying focused. It's a challenge for me, too. So I'm having to remember all of my tricks for how to stay productive while I'm working at home. All right, clean slate. Let's use my colored marker this time. Okay. So here's the problem. Rob rides a Ferris wheel. Oof, yikes, I can do better. There we go. So Rob rides a Ferris wheel that is 90 feet in diameter. Okay, so you see how I'm drawing a picture immediately as I look at this word problem? That's one of my biggest tips whenever you're doing a word problem like this is to draw a picture. Okay, so the diameter is 90 feet. Okay, big Ferris wheel, Rob is chilling up here, just minding his own business. You see Rob up here? Whee! Okay. Rob's up top. He's chilling. He's hanging out on this Ferris wheel. And the question asks, how far does he travel in 5 revolutions? Okay, so let's write that down. How far does he travel in 5? How far does he travel in 5 revolutions? There's a lot to unpack in that sentence, so we're going to do it step by step. And we're going to swap colors. Okay, so we'll use the green. So first step in a word problem like this is to draw a picture. So we have the picture, we have the Ferris wheel, okay, and we've got Rob, the most important part, okay? He's hanging out, having a good time. This was pre-coronavirus, when you could still do things like go hang out on a Ferris wheel, right? Okay, harkening back to a more simple time. Now we have to look at the sentence and figure out what it's actually asking us to do. Okay, so how far does he travel? Okay, how far does he travel? Well, when we think about this, we say, all right, he's on the top of a Ferris wheel, and he's probably going around in a circle, right? Has anybody been on a Ferris wheel? Okay, you're going around and around and around. Well, what is he doing? He's traveling the circumference of the circle. Does that make sense? Okay, so how far does he travel? Okay, that means we're looking for the circumference of the wheel. Okay, so we're looking for the circumference of the wheel. And then it says in 5 revolutions. Okay, so a revolution is once around the circle. Okay, but he goes around the Ferris wheel 5 times. 1, 2, 3, 4, 5, right? So 5 revolutions just means that he travels the circumference of the Ferris wheel 5 times. Okay, so now we can write a formula for what we're being asked to find. 5 times the circumference, which as we know is pi times the diameter. So far, so good? Yeah? Okay. So let's erase this now that we have a formula for what we're being asked to find. Okay. And honestly, that was the hardest part because we have the rest of the information we need, right? Okay. So let's start by figuring out what the circumference is. Okay. So pi times the diameter is going to equal pi times 90 feet, okay? So 3.14 times 90 feet, and that's going to give us approximately, let me see, pi times 90 feet. Let's actually do this all at once, okay? Pi times 90 feet, and then we're going to have to multiply all of that by 5, okay? So 5 pi d. We can do that because multiplication is commutative. Remember, it doesn't matter what order you do the multiplication in, it's going to get you the same answer. Okay, so 5 times pi times 90 feet. Okay, now we know that pi times the diameter, pi times 90 feet, if you get out your calculator, you'll see that this equals 282.6 feet. Okay? Now, that means that going around the circle 5 times is going to be 5 times this number. Okay? But I'm going to use the approximation signs to remind ourselves that we're approximating pi. We're not using an exact value because there is no exact value for pi. It's just an approximation. Okay? And that's going to give us, are you guys ready? 1,413 feet. That's how far Rob travels, going 5 times around this Ferris wheel. Does that make sense? Okay. Circumference is fun. It's easy. And you're going to be using circumference in your geometry projects by finding the circumference of the circular pool that you're going to put somewhere in your city, right? That's one of the items on your checklist. So I think that's all the circumference review I wanted to do today. I wanted to check in and make sure that you were working on your geometry packet at your own pace and that you were working on your cities. Make sure to send me a picture every day of your progress so I can see what's going on and help you troubleshoot any issues that you're having. If for some reason you're still having a hard time finding the PowerPoint and your review packet and the project checklist, just send me an email. All of those documents are in files on Rediker, so you should be able to get to them through your class page. And for turning things in, I'm still checking the Google Drive turn-in bins. I feel like that's easier than emailing me because you can just upload it when you're done, knowing that I'm going to go through and check it like I normally check the turn-in bin. Because you guys know at school, if you have anything to turn in, you can just put it in the bin. So I'm still checking the turn-in bins, so you can still use those, or you can email them to me. I think Rediker has a way of submitting assignments, but I haven't figured that out yet. We're all learning all of these new functionalities for things that we've been using for other things before. So I think those are the 2 safest ways of turning stuff into me. I think with that, that's all for me for now. I hope you guys have a great day, and I'll see you tomorrow. Okay, bye guys.